last session. And today's topic, we are going to start with public private IP addresses, then DHCP, DNS, IP config, TCP, UDP, MAC addresses, cabling types, communication types. Okay. So we'll see what we will cover up in today's session. A remaining portion we will cover up in the tomorrow's session. Okay, guys. So we'll start with the today's topic: public and private IP addresses. So on internet, we have to use public IP addresses, whereas for LAN, for the internal communication, we use private IP addresses. Okay. So these are the ranges for class A, B, and C private IP addresses. Okay. So class A range is pretty straightforward. You can see 10.0.0.0 up to 10.22255 is the class A private range. Okay. So all IP within this range will be covered under private IP addresses. Class B is little tricky. Okay. So 172.16.00 up to 172.31.255, only this range, this particular range is your private IP address range. So guys, I need to ask you on questions, and I need to understand your understanding about this, uh, that what will be the private IP address range in class B. So suppose I'm giving the IP address here 172.10.10.10. Okay, guys, tell me, is it a private IP address or a public IP address for class B? Is it a private IP address or a public IP address? All of you understood my question. My question is, yes, Sumit responded that's a public IP address, whereas Sheikh is responding that it should be a private IP address. Okay. Abraham is saying that it should be private IP addresses. Okay. Jiggy, public IP addresses. Okay. So guys, what where the range is starting? 170 to 16 onward, right? And 10 is before 16, right? So it is not in that private IP address range. 16 onward is the public IP address range. Okay. So this is the rule actually. Means only looking at 170 doesn't mean that it will be a private IP address. Okay. So let me give you one more. Let me give me a one more example. 172.20.20.20. Will it be a private IP address or a public IP address? So if you see carefully here now, 16 and 31, the second octet, if you focus on the second octet, okay, so will be it will be falling in the same range, 170 to 16 to 31. So we can definitely call it as a private IP address. Okay. Now let's take one more example, 172.40.40.40. Tell me guys, this is a private IP address or a public IP address? Ibrahim is saying it's public. Yes, 50. Everyone is saying public, and that's correct actually, because it's going beyond the range of 31.255 to 55. So we can call it as a public IP address. Okay. I believe all of you got this point. Now, the class C range is not that difficult to understand. First two octet should only be 190 to 168. Rest two octets can be anything, right from 0 up to 255. So if I take 192.10.10.10, okay, I think all of you can figure out this, whether it is a public or private. Public. It should be public because 192, 168 should always be there to have a private IP address. Okay. Rest two octets can be anything. Okay. So these two these two octets should be 192, 168. Okay. Okay. Then we have loopback address. This loopback address is 127.0.0.1. So what is the role of this loopback address? I think we have discussed this in the last session. If not, let me clear this. If I ping to 127.0.0.1, it gives me a reply back, and it means that we have our software, our hardware on the machine working for the network. Okay. If there is any issue on the networking part, that will get reflected here. Okay. So this loopback is used for testing purpose. We'll talk about loopback when we will have a practical sessions. Okay. Auto configuration range is 169.254.0.0 or anything we can take it here. This part, guys, I'll explain you when we discussed about DHCP. So upcoming point is DHCP. Let's have a practical on DHCP. We'll try to understand DHCP from practical's perspective. And along with that, we will discuss this auto configuration range also, this range 169.254. So guys, I'm going to take one small scenario here with packet tracer, and along with that scenario, I'm going to explain the theory of DHCP as well. So we'll take a small network here, one switch. Let's take few PCs. And then we'll take one server here. Let them connect together with straight cable because the devices are different. PC to switch. Okay, cabling part done. Let's decide what network we have to take here. 192.168.1.0/24. We'll talk about this slash 24. So actual subnet mask is like this decimal format. Okay, and this 255 means 8 1 bits. Then here we have 8 1 bits. Here we have 8 1 bits, and then we have 8 0 bits. So all 8 1 bits we have to take, okay, as a network bits. So 24 network bits. That's why I'm writing it here as a slash 24. Okay. So we will take a server here, and we can have a IP address statically or dynamically. So here we have option. Either we can take dynamic IP address or we can take static IP address. As far as server is concerned, what kind of IP address we should take? Whether it should be a DHCP based dynamic IP or a hard coded static IP. Yes, 50, we will talk about this afterward. Keep this question in a question answer session. We'll talk about that. Okay. And as you guys are responding on this, that it should be a static. So what is the reason we have to keep server with the static IP address? And the obvious reason is that PCs are dependent on the server for the services, right? So PCs can have a floating IP address or changing IP address or a dynamic IP address, but server should have a stationary IP address or a static IP address. If it is keeps on floating from one IP to another IP, server if has a floating IP address, the client machine cannot rely on the servers for, for the services. So we have to have a static IP address for the server. Okay. So for DHCP practical, first of all, we need a static IP address on the server end. Okay. 192.168.1.2 I'm taking. Okay. And gateway is not necessary in this scenario. So I'm keeping this gateway part, I'm keeping blank. Okay. And these client computer will take a dynamic IP address from this server. Okay. Why we need this dynamic IP address? Suppose if only 4 PCs are there, then it's useless to keep a DHCP server. Okay. Or it's more means it's not required to have a DHCP server if only 4 PCs are there, if only 2 3 PCs are there, even 10 PCs, within 10 PCs we don't require DHCP as such. Okay. What is the reason we have to use DHCP? If we have hundreds of machines, if we have 50 70, means large number of machines, so putting IP address manually like this is a difficult task. So going every computer and changing the IP address, it's a difficult task. It's a one time task, but it will be difficult if we make the changes in the network, because I told you IP address is a logical address. And logical address, if your logic change, means suppose we have 250 computers and afterward we realize that we require 500 PCs now because we have a company expansion. So we'll change the IP addresses. So you need to change the IP addresses on each and every computer. That will be a daunting task. That will be a tedious task. So what we can do, we will keep one centralized server to provide the IP addresses to all the client machines. Okay. And most of the enterprise follow this system to provide the IP address. And it is not only providing IP address. Beside IP address, it provides lots of other things as well that we will discuss soon. Okay. What other parameters are provided by the DHCP server? So how it works? So why we have to use it? I believe that's all clear for all of you. So, okay, that's clear for all of you. Now, how it works, that we need to understand. Okay, so this is the communication flow between client and server for DHCP. First message is a discover message and it's initiate from client machine. Okay, so what is the meaning of discover? Discover means finding out who is server and why this message is generating from client, why the server is not giving the IP address straight away to the client. The reason is, suppose on the floor we have 50 computer, or suppose we have 100 computers, but some of the employees are coming in the morning shift, some of the employees are coming in the general shift like 10 o'clock. Some of the employees are coming in afternoon shift, some of the employees are coming in the evening shift, some of the employees are coming in the night shift, different shifts for different people. So server don't know where which people or which employees are coming. So it's client's responsibility to acquire the IP address. So client initiate this discover message that I need IP address, I don't have IP address, and to be a part of a network I need IP address, and that IP address will be provided by server. But I don't know the server. Where is the server? First of all, I need to figure out who is the server in our network. So that will be a discover message. Okay, to find out, to discover out the server on the network. Okay, and this message happens to be a broadcast message. Okay, so let's check this message in the background. How we can check this? I didn't get your questions. Uh, DHCP servers processing power saved. Okay, I will keep your question pending in sessions. We'll discuss that afterward. Meanwhile, you also clarify your question. What exactly you want to ask? I'm putting this in a simulation mode, guys. DHCP. Okay, so I want to analyze the DHCP here. Okay. So I'm on the PC0 and I'll shift I'll shift to DHCP instead of static IP address. The moment I did this, see, the moment I did this, this packet is generated. This is the discover message. This is a discover message. Okay. So let's click on capture and forward. Meanwhile, I'll show you what's there in what is the content of this message. See, guys, this is the content of this message. It's a way to descriptive. I just want the basic details. Second, it is forwarded to all of the machine, and what's there inside, let's see. See, this message is hitting to all of the machines, but I told you this is server, but we have not configured it as a server, DHCP server. That's why all of the machines are discarding it. Even it seems to be a server, but it won't work as a server unless and until we configure the DHCP service. But let's see what's there in that request. This is a DHCP discover message, first message. So DHCP works on layer 7 actually, but on layer 4, it is a connectionless protocol with UDP with the source port number 68 with the destination port number 67. 68 is DHCP client and 67 is a DHCP server. Okay. Source IP address is 000 and the destination IP address is 255.255.255. Okay. Means we don't have any IP address on the client machine, this machine. We don't have any IP address and destination IP address is a layer 3 broadcast. Okay. Source MAC address we know. So that's a MAC address of PC0. Whereas the destination MAC address is layer 2 MAC address. Okay. So this message or this discover message is hitting to all the machines, but all the machines are discarding it, even including this server, because we have not configured it yet. Gurtej, check at your end because most other participants are not facing this. So guys, I'm removing this from the simulation mode. Okay. And I need to configure this server. So only static IP address is given on the server, but I have not configured a DHCP service here. So I need to configure it. So this service is off. So before making it on, I need to make few changes in the pool. This is DHCP pool. Okay. So gateway I'm not using as of now, but still in future I'll be using it. So I'm going to configure the first IP address of this network as a gateway. It's not required to be first IP address. It's not mandatory to be a first IP address, but I'm keeping it one. Okay. For the sake of simplicity. Start IP address, I'm going to start with 10. Means if this is the first computer, it will be going to get the IP address 10 here. Okay. Then subnet mask, okay with that. then maximum number of users. Suppose I have 50 user maximum. In diagram I just shown 5 users or 4 users, but suppose I want to extend it up to 50, so I'm keeping it up to 50. Still, as switch static is used in mostly on enterprise, I mean which class is used. So it depends on the size of the company. Most of the time we use 10.0.0.0 network with the subnets. We'll talk about subnets afterward, Sheikh. Okay. So this 50, I've configured maximum user, then save, and this all things are set, but it's yet not on. So let's make it on. Now this DHCP server is ready to serve the client machine. Now this time if I raise a request, it's already done in the background. Okay. So I can't capture it now because it's already done, but I can do a capture on the second machine. So before going to DHCP tab, what I'll do, I'll put it in a simulation mode. Okay, DHCP is already in under analysis, and I'll click on DHCP. The moment I did it, in the background, this got generated. So point to be noted on this display is 68, 67 UDP. Source DHCP client is UDP 68, DHCP server is UDP 67, source IP address is all 0, destination IP address is all 255. That's a layer 3 broadcast. Source MAC address is unicast MAC address of PC1 LAN card, whereas destination MAC address is all F. Okay. Now, when this frame will hit to switch, and switch sees that the destination MAC address is all F, it has to be forwarded to all of the machines. All other machines are discarding it except the server. So guys, we have studied encapsulation and decapsulations. So when this frame reach to PC2, it will be on physical layer. Then on data link layer, it will be checked. FCS is okay, frame check sequence. Then it will check destination MAC address. So destination MAC address is what? FFF 12 time F, means all F. So that will be accepted by PC2, PC3. Then it will be checked on layer 3, that is destination IP address is all 255. That will also be accepted by PC2, PC3, PC0, even server 0. Then it will be checked on transport layer. Protocol is UDP and the destination port number is 67. So that UDP port number 67 is only open with server 0, and that port is closed with PC2, PC3 and PC0. So they are simply discarding it, whereas server 0 is accepting it. So it forms one sessions and it will be analyzed on presentation layer, then it will be analyzed on the DHCP's server. Can we provide IP address from the pool of IP address? So guys, last IP address is assigned to PC0. What IP address is assigned on PC0? As you can see from the screen, 192.168.1.10, and we have configured a DHCP with start IP address of 192.168.1.10. That's been already allotted to PC0. Now the second machine is PC1. So logically, what will be the next IP address offered by the server? That's the second message. Offer message from server to the client. So what could be offer from server to the client? You can answer in a chat board if you know. It's very simple. 10 is already allotted. So then sequentially 192.168.1.11 will be offer from server 0 to the PC1. Okay, correct. So let's check this. I'm going to open this. Okay, in outbound PDU, if you check here, your client address is 192.168.1.11. Okay, and this message is sent by server, DHCP server, that's UDP 67, and destination IP address is UDP 68. Okay, and on IP level we don't have fixed IP address on PC1. That's why it is a a layer 3 broadcast. Okay, and again a layer 2 broadcast, because this IP is yet not fixed with any of the computer, so it's a broadcast message again. Okay, so other computers will discard it because that port number 68 is not activated on PC2, PC3 and PC0, because DHCP client has not raised a request from PC0, PC2, PC3. That has been only raised by PC1. So PC1 is going to accept it. Okay, and then PC1 will respond back with the message called as request message from client machine to the server machine. So guys, next message is initiated from PC1, that is a request message from PC1 to the server. Okay, and at the end we will get an acknowledgement message from the server to the PC1. Okay, and it's still a broadcast because till this point we don't have any static IP address, any fixed IP address on PC1. It's not yet confirmed. When we get this acknowledgement message delivered to PC1, this point onward whatever communication will be generated from PC1 will be a unicast communication. Okay, uh, because IP is fixed on PC1 now for a particular lease time. So that's the last message, this acknowledgement message coming from server to the client. When we get this acknowledgement message, server put one binding on the server message that the MAC address of client machine and the IP address 192.168.1.11 will get binded for a particular lease time. So lease time in normal scenario is about 1 day. I can show you lease time on my machine. Okay, so if I go to, see guys, here I'm having my lease obtained time and the lease expired time. Okay, so Wednesday April 10, 7:41, Thursday April 11, 7:41, means near about 24 hours lease time we have here. Okay, so in normal scenario we have to keep it 24 hours. In certain scenario where wireless is means 8 hours we can customize. In certain enterprise businesses we have to keep it in 8 hours. Okay, in some certain situation we have to keep it 24. Default is 24 hours, but we can change it to 8 hours if required. Okay, so this is all about the different messages: discover, offer, request, acknowledgement messages.
malam barka muna lafiya ka gane mu unguwa la visibility quoi yanzu le monde a changé.
Okay, Jiggy, this difference between unknown unicast and unknown unicast frame, that's not relevant on this topic. Actually, this is for switching point. I'll explain you where we use unknown, where the unknown unicast frames are, how the unknown unicast frames are treated and what is the meaning of that. That will not be relevant here. Okay, I'll explain this point in a switching part. Okay, basic switching part. Any other questions related to DHCP? If you have, you can raise that question here. So these are the four messages: discover, offer, request, acknowledgement. I believe all of you are clear with this. And we have some other messages also: release and renew. Okay, that I can show you in a short while. I'll show you that as well. Okay, let me remove it from simulation mode. So we are in the real time mode. We got this IP address here. Okay, suppose when PC2 want IP address, and at the same time at the same time this DHCP server disconnected from the switch. Okay, so what will happen? This PC2 will raise a request from the client machine. PC2 will raise a request from the client machine, but it will not be able to get the IP address from the DHCP server. So at the end, it will take the IP address as a APIPA IP address 169.254.219.140. Okay. If another computer also try to get the IP address similarly as asking for DHCP, so it will also get a IP address 169.254.3.138. Both will get different IP address. Uh, Guys, my question to all of you: this address is assigned by the operating system itself, and that process is APIPA, automatic private IP addressing. But how they assured that how they assured that this IP will not get duplicated? This 169.254 will be constant here, and 169.254 here also constant, but the last two octet keeps on changing. Hmm? How they assure that this address will not be duplicated? Because see, in previous point when DHCP was there, that time DHCP is taking care that no one will get a duplicated IP address. It keeps a track that if 192.168.1.10 is allotted, we are not going to assign 192.168.1.10. We will assign 11, then 12, then 13. That that thing will be keep track on the server. But here PC2 gives the IP address to itself because DHCP is unavailable, and it ensures that the last two octet will not repeat with any other computers as well. With any other computer as well. Okay. So how come this is possible? How come it will be a possible thing? Anyone know how PC2 ensure that PC3 will not get the same IP address? Here we have 219.140. Here we have 3.138. But the first two octets are same. Guys, you understood my question? DHCP server is unavailable. So we are assigning IP address with the automatic private IP addressing process. Okay, the operating system itself assigns the IP address. Okay, and it ensures that IP address will not be a duplicated IP address. How come it will be a possible? So answer for this is GR. That is gracious R. Yeah, it keeps on changing. The last two octets keeps on changing, but it ensures with the help of GR. So how it works? Let me show you with one more computer. So let's connect one more computer here. Okay. Let it turn into G stands for gracious ARP. This GR in GR, the G stands for gracious ARP. So how it works, I'll tell you how it works. So it is in the orange state. Wait for a few seconds. It will turn into green. Yes, it is now in working condition. Okay. And it is in the working condition. Okay. Uh, and we will put this in a 1 second. So we have to analyze this on ARP. Let's put a DHCP here. See guys, one GARP message has been generated. What you can analyze from this 169.254.103.128, 122. This is source IP address and this is the destination IP address. Okay. And source MAC address is the MAC address of the source MAC address is the MAC address of PC4, whereas the destination MAC address is the MAC layer 2 MAC address. Sumit, will it work in scenario where we have more than 255 hosts? That will work there, but that's not the reason we are using it. This we used. Suppose you have a laptop and you have a desktop. Sumit, we'll talk about this host point of view, but try to focus on this analysis now. See, we are going to assign IP address 103.122, 169.254.103.122 on PC4. But before assigning this, what we will do, we will send this packet to all of the computer. Okay. And if any of the computer has the same IP address 169.103.122, that will respond back, right? And if we don't have the same IP address, nobody will respond back. Okay. And then we will ensure that this IP is not assigned to any of the computer, and it's okay to assign this IP address on PC4. So PC4 will have that IP address. And this is not for APIPA only. This is for static IP address also. This GARP is used in static IP address also. This GARP is used in router also. Any computer who is going to use IP address at the first stage, they start sending this IP GARP message to ensure that the IP will not get duplicated elsewhere. And if IP is not duplicated, we will not get a reply, ARP reply from any of the computer. But if the same IP is used at multiple, if same IP is used in any other computer, that particular computer is going to reply me back. I believe all of you are clear with this. If not, I'll give you one general analogy for this. See, in the classroom, we have a rule that no student, even including trainer, will have a same name. Okay, this is the rule, suppose. So when we join the class, we have to declare that my name is Samir. So no one will have, and I'll declare this in a broadcast way. My name is Samir. Source is Samir. Destination is Samir. Source is me as a physical address. Destination as a all student. So if anyone has a name Samir, I need to change my name logically, like Samir1. Instead of Samir, I'll take Samir1. So that will ensure that I don't have a duplicated IP address. I don't have a duplicated name. Similarly, when PC4 assigns the IP address, at the same time it sends a GARP message that the source IP address as 169, that particular IP address 169.254.103.122, and the same IP address as a destination IP address. Source MAC address is the MAC address of PC4, that is 00D0D309677A. I'm looking at the screen and from there I'm telling you this. Okay, and the destination MAC address, what will be the destination MAC address in GR? If you know the answer, guys, you can reply in the chat board. Correct. The destination MAC address will be all F or a layer 2 broadcast. So all of the computers will receive this message, but they are simply going to drop it if they don't have the same IP address. But if they have, any of the machine has same IP address, they they are going to that particular computer is going to reply back to PC4, and then PC4 will will stop using that IP address. Instead of that IP address, it will use some another IP address, and again it will generate a GR message, and again it will confirm that no one has the same IP address assigned. Clear with this? I believe this is clear for all of you. If yes, you can respond as yes in the chat board. Clear? Okay, guys. So we are done with DHCP and the APIPA also. Okay, private IP address. Now, guys, we have to look at the DNS part. So let me stop this in simulation mode. Let's come back to our slide. Before looking at DNS, let me explain you about the IP config, release and renew functionality. So hmm. So see, this PC2 got a PIPA IP address, PC3 got a PIPA IP address, PC4 got a PIPA IP address. Suppose when in the morning shift, PC0, PC1 employee came and they got the proper IP address. In the afternoon shift, PC2, PC3 and PC4 employee come and they realize that they are not able to communicate with the server, the important server. Suppose they have one of the important server as a FTP server or some Active Directory server, and these computer even don't allow the client users to log into the, because Active Directory is also disconnected. All important services are disconnected because they got a wrong IP address from the APIPA. They got the IP address, they have not received the IP address from the DHCP. So they call the network engineer that we are facing some issues related to networking, can you help me? So we realize that our DHCP server is disconnected. Okay, so what we do, we will first connect our DHCP server to the switch. We will ensure that it is up and running. So it should have this orange light blinking. Once we do that, then we go to the client machine. Okay, and we will go to this command prompt. Okay, and here we will see that IP address is the wrong IP address. So what we will do, we will release this IP address. So this IP address is released. Now I'll renew this IP address. Again, discover offer request acknowledgement message will be generated and in the background, and we will get a correct IP address this time. Similar procedure I'll repeat on PC3, or we can do it from graphical also, static and DHCP. Okay, or we can repeat it via command prompt. IP config slash release and renew. So we got a correct IP address. Clear with this? Release, renew. So sometimes we have to deal with a computer which are only running with command prompt, or sometimes we have to use batch file to rectify our issues. Okay, so we should be aware of the command prompts also, and things works pretty fast on the command prompts. Okay, so that is the one thing we have to use is batch files and all these things. Okay, so just running a batch file will solve our purpose. So release, renew, done. We have display DNS, we have flash DNS. That we'll talk in DNS discussion now. Let me arrange this. So guys, this is the basic purpose of DNS. Like client is asking for the IP address of www.google.com, and DNS server is responding back with the IP address of Google server. But now think from the broader perspective, that suppose we have a small network here with a switch connected with PCs, and it is furthermore connected with a router, and that router is furthermore connected with internet. Like this. Okay, and now we'll try to understand this DNS case by case. Okay, so suppose I want to access www.google.com, and this website is already accessed. This website is already accessed by one of the one of the employee on the same computer. I'm working on this first computer, PC1, and on this computer, this website is already accessed. Okay, so what will happen here? It will be accessed from the DNS cache. Okay, so it's already there, and once we get the IP address resolved for google.com, it will be there for the next 24 hours. So this default timer is 24-hour for DNS cache. So once we have this google.com, it will be there for 24 hours. So suppose 9 o'clock someone has already accessed google.com, and 11 o'clock you are asking for again the same website. From the cache itself it will be available. The IP address of the google.com will be available from the cache itself. So you don't have to contact to the DNS server. Okay, so this is the first case. Now let's consider another case. Case 2. Suppose we are trying to access a website www.cisco.com. This website no one has accessed on the PC1. Okay, but PC2 already has accessed this website. But we are not going to ask to PC2, rather we will be asking this to the DNS server. DNS server. So suppose guys we have one small setup. So this router is also acting as a DNS server. So router plus DNS server. Okay, so the IP address here is suppose 192.168.1.0 network, and the router address is 1. Okay, and this client machine will ask to the server that what is the IP address of www.cisco.com, and suppose we got the answer from DNS server. Why? Because PC2 has already accessed www.cisco.com, so that is already cached on DNS server. So we got the IP address from DNS server there. Okay. Now let's consider case 3, where neither client machine, neither this machine or another client machine has access the website like www.microsoft.com. So this website is not accessed by any of the machines within our LAN. Then what will happen? So our DNS server is configured with the setting called as forwarder DNS, and that forwarder DNS is our ISP DNS server. Suppose this connection is taken by the company. Suppose we are taking connection from Airtel, okay, and they have their own DNS server, and that DNS server IP address will be configured in our router come DNS server as a forwarder DNS server. Means if our DNS server don't know the answer, that answer will be raised to forwarder DNS server, that is Airtel's or ISP's DNS server. Okay, so the query will be forwarded to the ISP DNS server. So we are one of the client, like we are first client, client 1. Like this, they have client 2 as well. Like this, they have client 2, client 3, client 4, and they have hundreds of clients within this area or within this location. DNS cache rush is stored on operating system. It's present in the operating system, and I'll tell you what commands will be used. So this commands will be used to see the cache display DNS. Okay, so it is on the computer itself, and if you want to remove that, we can remove it with flush DNS, and in certain situation we have to flush it down. We'll talk about that. So we are talking like this, like this client 1 is asking for microsoft.com. No one knows about this, means like our DNS server don't know about the answer, so it will ask that same query to the Airtel DNS server. Airtel DNS server is already aware of this reason. Client 2 is, means the second customer. This is one company, this whole is one company. This is my company. Likewise, we have client 2 also, another company, and that is also connected with the ISP. Okay, so from another company, someone has already asked about microsoft.com. So my Airtel DNS server already aware of the IP address of microsoft.com, so that answer will be given readily to our DNS server, from our DNS server to PC1, and then PC1 will get the IP address, and from there it will send a HTTP request on microsoft.com, and we'll get an answer on that, or we'll get a HTTP response or web page loaded. Clear with this case 3? DNS cache will DNS cache will be there as long as the PC is on. Okay, it will get flushed out when we restart the computers. Okay, it's a dynamic cache. Okay, so now I'm going with the fourth case. Suppose, let me adjust the screen here for the fourth case. The fourth case is like this. Case 4. I want to access www.pingster.com, this website. Okay. I need to adjust the screen. So this pingster.com website is not accessed by any of the client, any of the user on the same machine. Neither it is accessed by the other client computer. So our DNS server is unaware of this. Then another, yeah, website name. Let's change the website name. We will change it. We'll keep it as a pingster.in because our website name is pingster.in. Let me write it again. .in, www.pingster.in. So this website is not accessed by any of the client computer, and Airtel has suppose hundreds of customers, but no one has still accessed this website. So this website is not on the cache of our DNS server. This website is not on the cache of Airtel DNS server. So it has to be means when our this ISP DNS server will cannot give a blank answer that I don't know where is pingster.in. That's not possible. So what will happen in that case? In that case, the root server will come into the pictures. Okay, it's called as root server. Then let me first just draw this servers, different servers. Write it here. Then root server will come into the picture. It's dot, actually we call it dot, and root server. Okay, so guys, when we have a website like www.pingster.in, it is basically under root is .in. So .in is your top level domain. It's called as TLD, top level domain. Like this we have .com also. Okay, like this we have .jp, .pk, like this. Okay, so we have multiple top level domain. You may also know that .org, .goe. So under root, all these top level domains are there. Okay, so the first query will go to root server. Then root server will give a partial answer that you contact to .in server. So the next query will be raised to .in server. .in server has a registration for www.pingster.in. Okay, so that query will be responded with pingster.in DNS server IP address. Okay, thanks, Rosh. It's a router actually. Okay, so it goes to DNS server. So second query, let me write it here. First query will go to root server. Second query will go to .in server, and third query will go to pingster.in, DNS server of pingster.in. Okay, so this pingster.in has a DNS, means domain as pingster.in. Under that we have www.pingster.in. dot in. Under that we have mail dot pingster dot in. Under that we have ftp dot pingster dot in, like this. Okay, even this www.pingster.in is also, means we have three servers. Okay, and all three servers have different IP address. So here we have IP address IP1. I'm not writing the whole IP here. Okay, I'm just writing IP1, or let me add this, I can write that as well. Okay, so let's adjust this here. Like suppose we have 100.1.1.1 as www.pingster.in, then we have 100.1.1.2 for mail.pingster.in, we have 100.1.1.3 for ftp.pingster.in. Three IP address we have taken, three server we have, but this particular entry is a alias entry. Means actually we have in our company two web servers, server 1.pingster.in and server 2.pingster.in. Primarily only server 1 works for websites, but if my server 1 goes down, server 2 starts working. Okay, but no one in the world know that server 1 is down, that's why server 2 is working, because we are known to the world by the alias or the canonical name or a nickname as www.pingster.in. They don't know the details that exactly who is serving, server 1 is serving or server 2 is serving. And pingster.in DNS server keep hold of all these entries. So it is authorized over all this. So one authorized server, authorized response or authorized answer, authoritative answer will be given to ISP DNS server. That will be then a cached answer from ISP DNS server to the our company DNS server. Then our company DNS server also cache it and give a non-authoritative answer or cache answer to the client machine, and then client machine will be able to connect with web server. Any doubt so far? Clear with this? Guys, we will have a question answer session now. Rest of the points we will cover after question answer session. Okay, I believe IP config is clear, DNS is clear, DHCP is clear, public private IP address is clear. Okay, TCP UDP discussion I'll keep pending because it requires some more time to have a discussion. So tomorrow with the fresh start, we will discuss upon TCP, UDP, three-way handshake, sliding window, all the concepts. Then cabling. So tomorrow we will be finishing all this stuff, network fundamental stuff. Then we'll move to the routing part. Guys, any question if you have, you ask me. If a DNS cache doesn't have any entry on a particular domain name, will the system send a broadcast or unicast? Okay, so as we have discussed in our here, so if we don't have an entry on our DNS cache, that's the first case. So the query will go unicast to the DNS server. Whatever entry we have on the DNS server, that will be seen. Okay, guys, we can do a practical also for this, so it will become more clear. In a quick shot, I'll explain you with the practicals how it can be configured. It's a good question, Roshan. So it will get clarify how. So I'm going to take few more server. So this first server already configured as a DHCP server. Okay. Second server I'm going to configure as a DNS server. Third server I'm going to configure as a web server. and the fourth server I'm going to configure as a FTP server. Okay, let's connect them together and let them give the IP address. Okay, so this first DHCP server is already assigned with the IP address 192.168.1.2. Uh, in packet tracer, if you just take a mouse over that, it will give the IP address. But in real scenario, you have to go to the configuration setting and check there, or else you have to check it from the command prompt. Okay, and the command for that is ipconfig. Then let's go to the second server, that is our DNS server. So guys, we are working on this server now, the DNS server. So we'll go to IP configuration part and we'll give a static IP address 192.168.1.3. Okay, and we'll give the IP address on web server 192.168.1.4, and we'll give the IP address on FTP server 192.168.1.4 5. So guys, 1.1 we are keeping reserved for router. 1.2 we have assigned with DHCP. 192.168 1.3 we are assigned with DNS server. 1.3 we assigned with DNS server. Web server we assigned with 1.4, and FTP server we assigned with 1.5. Yes, Rosh has asked questions. How does system know the IP of DNS? Will DHCP assign IP address dynamically to DNS server, web server? That I'm going to configure here. Okay, so see, I need to configure DNS server here for this particular practicals. So I have to go to the services section and I have to check this DNS part. So it is off now. So I'll before make it on, I'll give the name www.pingster.in as a website name, and I'll give the IP address 192.168.1.5 because 1.5 or 4. Web we have taken 4 I believe, and 5 we have taken on FTP server. So we'll take IP address 1.4 here. I'm going to add that. Yes, Roshan, I'm coming to that configuration. First, we have to configure the DNS, and that particular entry we have to use in DHCP. Just uh, give me some time. I'll configure this and I'll show you how it works. Where it is. So one more entry I'm going to put ftp.pingster.in, and the address for this is 192.168.1.5. Let's add that as well. Okay, and this DNS is ready. Okay, this DNS is ready. If I go to if I go to web server and if I open the website www.pingster.in, it's not going to work. Reason, DNS is ready, but DNS only responds. DNS is not ready. We have to switch it on. So DNS is ready now, but DNS is only respond when we know that query should be forwarded to DNS server, and that only be possible with the help of IP setting. So in our IP setting, we don't have DNS server, as you can see here. ipconfig will not show you the details about DNS, but if you run ipconfig/all, you see here DNS server is not yet configured. Reason, it's not provided by my DHCP server yet. If you go to the DHCP server setting, the DHCP server and services and DHCP setting, we have kept the DNS server 000. So we need to provide this IP address of DNS to the client machine via DHCP server. Rosh, I believe now it is clear for your query. So what is the IP address of DNS server? We have kept 2 and 3 here. Okay. So DNS server is 3 and DHCP server is 2. 192.168.1.2 on DHCP server, 192.168.1.3 on the DNS server. Okay. Uh, it is configured in DHCP. Let's see here. 1.3 we have to take 1.3. Okay. So this setting I changed, but I have not saved it. So I need to click on the save button. Now it is saved. So client machines still don't have DNS server settings, because once we get the IP configuration from the server, we are not going to change it unless and until you manually change this by a release and a renew command. Okay. Okay. So now it is changed. Now it is changed. Yes, Mehndi, that's what we are doing also here in this. Okay. Okay. So I believe this will work now for PC2. For rest of the computer, it's not going to work, but for PC, it's going to work now. So for PC2, it's going to work. www.pingster.in. Yeah, it's working now. So my web server is already configured. If you see here, websites are already working. If you want to cross check it doubles, we can make the changes here. Welcome to Cisco packet tracer. Let's remove this. We'll change it to Pingster. Okay, welcome to Pingster. Now we'll do it from PC1. Still it will not work. Reason, this PC1 doesn't have DNS entries, DNS servers entry. So if I run all, we'll get this DNS server is not yet there on this particular computer. Release. So all IPs released. Now I'll configure it with renew. Soon we'll get it. Okay. So DNS server is there now. Let's go back to website again. www.pingster.in. We have not saved, I believe, that website settings. Yeah, we need to save this page so it will work then. So it's saved now. If I go again to PC1 and refresh this page, you see, welcome to Pingster. Okay. Now let's try with FTP site as well. So on PC3, I'm on PC3 now. Okay. If I release this IP address from graphical, it is also possible. And if I raise a request again, this time I'll get a DNS server. Okay. Once we get a DNS server, we'll go to command prompt and we will send a request like ftp dot pingster dot in. So is there any username and password? See here on FTP server. I'm on FTP server. Let's go to FTP server settings. So this service is on, but only one user is configured. Cisco with read, write, delete, uh, and rename and list all is there. Suppose I want to add one more user, so I can add that user also. first I have to remove this. Okay, I'll add a user like Pingster user password. I can't keep space in between, so I'll just keep it Pingster. Then password is I'll keep ABC, simple password, and all the rights are there for Pingster as well. Where we were on PC3. So on PC3, I'll give that username Pingster. Again, I'll try one more time. I think we have not saved the setting. It's not working properly for this user. Maybe the first you. Let's check if it is a case sensitive. Password is ABC. Yeah, now it is working. And what commands are supported on FTP? These are the different commands supported on FTP. Sometimes we have to deal with FTP server also, so we should be familiar with these things. Okay, so what files are available on my FTP server? You can see these are the different files available on my FTP server. Okay, let me check the size. Let's take any of the small file if we have any here. Let's check. Let's take this file here. I don't know what this PT, or let's take another file. This is a ISO, means operating system image. Okay, let's copy this. Let's copy this. And is there any command which will download this file to my machine? So we have put command and we have get command. Get command means download and put command means upload. So let's download it. Get, then the file name. So if you see in the background, FTP server and PC3 LEDs are blinking with this animation. It means that it is blinking. It means that the transfer is ongoing. We are downloading the file. Once the download is complete, then again it will go to the stable state as the other computer. Okay, just wait for a while. It will complete the download. Then we will have that file at the PC3. Any other questions, guys? Beside this, I believe your queries is cleared. Roshan, is it clear for you in production environment how does works? Okay, and other guys are also clear with this, that this is the one of the important, means like a good questions for other will also get insight on this, means like how DNS works. We can have a static IP address also as a DNS IP address, but it's not required most of the time, because otherwise we have to manually put there. Better we will give the same setting through the DHCP. Okay, this is taking more time because this file is bigger. Okay. Any other questions, guys, beside this, whatever we have discussed so far on a DHCP, on a DNS, okay, on private address, on public address? My questions for you, that public addresses we have, okay, and private. So if I use public address within my company, okay, suppose four computer, or suppose I have 10 computers, I'm using 200.1.1.10, and if I use a NAT system, okay, so will do I have to use only private IP address, or can I use the public address as well? It's still on progress. Guys, I need to share the feedback link with you. Let me check this where that link mail I have. Okay, second. I'll give the feedback link in a short while. Just give me a minute or it is. This feedback link I'll put in a chat box. Guys, go through it and forward fill up this. Okay, guys, try to fill up this survey. That will be helpful for us. Uh, okay, we'll stop here. Most of the points for today's we have covered. Rest of the points we cannot cover in today's session. That we will keep pending for the tomorrow's session. Okay. And my question, anyone understood that question? Can I use public address in LAN? Okay, Jiggy has responded only private LAN, private for LAN. That's true actually. Only private LAN we can use. We do not give destination path in PC. Where will it get saved? So, mm, did not get destination. I didn't get your questions, Munna. And Jiggy, your argument is absolutely correct, and that's logical as well. We have to use private. But if we go with the public, we can assign public. No one can stop us to assign public. But when we go on the internet, we cannot go with that public address. If we go with that public address, it's that communication will not be possible. And we have to use a public address which is assigned by the ISP only. Okay, so it's going to create a problem. Okay, on a long run, if you use a public addresses in a LAN, and what exact problem we will face, that we will discuss in a NAT discussion, network address translation. So a small problem we will face, but that could be a big problem if the servers are in the same range, public servers are in the same range that we are using. Okay, we'll talk about that later on, but the general rule is we have to use private addresses in the private network. Okay, okay guys, we'll close this our discussion, today's discussion. Thanks for attending the session. See you tomorrow in tomorrow's session. Good night.